It's now time for a linked list challenge. I'm going to ask you to use linked list functionality to create a list of places ordered by distance from the starting point. I want you to use a list iterator to move both backwards and forwards through this ordered itinerary of places. First, create a type that has a field for a town or place name and a field for storing the distance from the start. Next, create an itinerary of places or towns to visit, much like I've been doing in the last few videos. But this time, instead of strings, you'll want to create a linked list of your place or town type. Here I show a list of a few places in Australia and their distances from Sydney. You'll create a linked list ordered by the distance from the starting point, in this case, Sydney. Sydney should be the first element in your list. You don't want to allow duplicate places to be in your list for this data set. In addition, you'll create an interactive program with the following menu item options. The menu will have options to move forwards and backwards through your itinerary, to list the itinerary, print menu options, and quit the program. You'll want to use a scanner and the next line method to get input from the console. You'll use a list iterator to move forwards and backwards through the list of places on your itinerary. Okay, now pause the video and have a go at building this, and when you're done or want to see the way I'll build this, come back and we'll walk through it together. Pause the video now. Welcome back. I hope you found this an interesting challenge. I've created a new project named Linked List Challenge, set up in the normal way. The challenge said to create a type for the place or town to visit, or the itinerary item. Did you create a class for this? That would have been a good way to solve it, but Java does offer a much easier option, the record. I'm going to create a record and put it in the main.java source file, record place with parameters string name in distance. By using a record, I have a constructor, accessor methods, and an overridden toString method created for us implicitly by Java. Next, I want to set up a linked list of these records in the main method. Linked list of places to visit equals new linked list diamond operator parentheses. With this code, I'm saying that places to visit is going to contain a linked list of my place records. I could use any of the add methods on linked list, but I want to create my own method called addPlace. This code is going to let us add the place in order of the distance from the starting place and also check for duplicates. This will be a private method taking a linked list of our place records as well as the place record that should get added. I'll start by adding the place to the linked list with list.addPassingPlace. This code right now just calls the add method. However, I don't want to add the place if it already exists in the linked list. Let's add the code that checks for that. Does list.contains_passingPlace find a match? Yes. I'll print a message confirming that along with the place itself. Exit the method. Hopefully you've remembered that lists have a method called contains. This checks for a matching element, so if this method finds a match, we'll just return from this method, meaning the item won't get added because it's already present. Let's see what happens when I call this method from the main method. I'll create a new place for Adelaide, my hometown, also passing the distance from Sydney, which is 1,374 kilometres. I'll call our addPlace method passing places to visit and Adelaide, and print the list. Right, I've added Adelaide, which was in the table of data on the slides shown earlier. Then I call addPlace, passing the linked list and this new record. Shouldn't be any surprises when I run this now. We get confirmation that the list includes the Adelaide place record. This is the default string representation for a record and includes the class name, the record field names, and values. I want to simplify this, so I'll go back to the place record and add a couple of lines between the brackets in the record body. I'll generate an overridden method for toString, and I'll replace the null with a formatted string that looks like this. Hopefully, you remember that the string.format method takes a string with format specifiers, and we pass the values name and distance. Let's see how the formatting has changed by running the code. I get a simpler string displayed, and this will be easier to look at when I have more places in the list. So now let's test to see if I can add a duplicate record. I'll try to add a new place record for Adelaide again. As you can see, I use the exact same data as the previous record, and I just create that in the second call to addPlace. Will this be treated as a duplicate? Let's find out. Success. You can see that this was recognised as a duplicate record and was not added to the list. So that's good. This works because Java includes implicit code for the record which tests the equality of all its fields. If all the record's field values match another record's field values, Java recognises that the records are equal. This means we can use the contains method to find a match for records, so that's a pretty neat inbuilt feature of records. Next, I'm going to change that second record to have Adelaide all in lowercase. I get two Adelaide records, one uppercase and one lowercase. This isn't the behaviour I want, so I want to write my own test, looping through every element in the list. For me, a match will be a match when the place names are the same, ignoring the case, and I'm not going to compare the distance fields. I'll use a for each loop for our list. Ignoring the case in the name, does the place name we are trying to add already exist in the list? We found a match, so I'll indicate that with a message, and then exit without adding the place. In this code, I've got an enhanced for loop with a local variable p, which is a place record. I compare each record in the list with the one I want added, comparing the name field values on each record, ignoring the case. The implicit accessor is not getName, but just name on records. Will this code reject our all lowercase Adelaide now? Let's find out. I get found duplicate Adelaide 1374, and the list still only has one record. So that's great. Now that we've handled duplicates, I want this method to add each new place in order by the distance to Sydney. I want the closest place to be first and the farthest place to be last. I'm going to use a simple enhanced for loop for this. Int matched index equals 0. Traverse through the list using this for each loop. Increment matched index. First, I create an index variable which will keep track of what element position is being processed, and we know we want to start at 0 to work on the whole list. In the loop, we increment the matched index variable in each iteration. We're not done yet. I'll now add the code to compare distances between the record I'm adding and the record we process in the loop. Is the distance for the place we are trying to add to the list less than the distance in the element we are currently looking at in the loop? It is less, so we want to add it here. We do that with a call to list.add using matched index and place as the arguments. Now that it's been added, we can immediately exit the method. I use the accessor method distance and compare that to the loop variable listPlace.distance. If the new record is closer to Sydney, I'll add it using the add method that takes an index and pass it the matched index. Then I'll return from this method once I've added the element. If I get to the end of the loop, I know I still need to add the element, so the list.add code below this for each loop will get executed, adding the place to the list right at the end. I could have used a list iterator, and it could be argued that might have been a bit more efficient. That's because an indexed add for a linked list has to loop through the elements again to find that index and place that element. But when you're dealing with just a few elements, as I am here, sometimes it's preferable to use code that's just simpler to use and read, like this. Let's go back to the main method and add all of the places on the slide. I'm adding these in no particular order. I'll copy the Adelaide statement on line 21 and paste it, changing the variables each time. First, Brisbane with 917 kilometres, then Perth at a massive 3,923 kilometres from Sydney, Alice Springs 2771, Darwin 3972, and finally Melbourne 877. Okay, there's our test data. I'll run this code now to check if everything is working correctly. You can see that my itinerary is ordered by distance to Sydney from closest to furthest away. Let's add Sydney as the first place in our list. Places to visit.add first, passing a new place record with the arguments Sydney and 0. I used the add first method, a method that's on linked list but not on array list, to ensure this was the first entry in the list. Let's run this now. And Sydney now correctly shows to the left of the entries. Okay, so let's end this video here. In this video, I've created an itinerary, ordered it by the distance from our starting point, and prevented duplicates from being added. In the next video, I'll add the interactive part of this challenge. I'll see you in that next video.